Okay. Okay. Here we are again. At last, but not least, it's November number 19. So, welcome back on this little journey around body study and some Unity and some compute shader and some shapes and some design, etc. etc. We have some nice tea here, a nice smooth jazz in the ears. I think we're ready to begin. Okay. So, as usual, a quick disclaimer about the stream on Instagram, because Instagram might crash sometimes. The stream is not really stable, so if the stream just cut, I will restart one, but if it crashes 3 times, I will simply stop the stream on Instagram and continue the stream on Twitch. So, that has been said, let's try to continue our little experiment. This is the experiment we've made yesterday. I wanted to play with some skull, and so we had some bones, etc, etc, and the main idea was to have the bones and the skull and basically having a 3-time animation, so the bones fade in, then it will just blend, the shape will blend into a sphere, lighted sphere, and then the light will go up, and it was inspired by the movie Coco. So it was a little bit creepy and also a little bit cheery with the lights. I think tonight I want to explore something more joyful and less creepy. So go back to something I think a little bit more simple. And I think I will play with sphere, also because I still have my problem with rotation matrix, as we saw yesterday when we played with the matrix. The rotation matrix, it seems we have some error inside this rotation matrix, so I'm not sure about this part. So I need to retake the matrix computation and the way we applied it on the. I think this weekend I will try to change it. An idea would be to just binding the identity matrix to the vertex shader, just to in the setup function get just the position, and then try to rotate each vertices directly in the vertex purely. So that would mean also rotate the normal, of course. But this is something. In order to do that, I would need some time, so I'm not sure I will do that tonight. So I think I would go with something more simple. So I still have some various ideas to explore, and I think, let me just show you. I will cut this play here. So let me show you something I just saw tonight, and which gave me an inspiration, and I said, oh, of course I might explore something in this area. So this is the feed I saved on Instagram. There is a lot of great artists, and And one inspiring thing I thought was this one, which remember a Japanese artist I've seen few years or many years ago, which worked with a lot of dots and balls, like a pink a sphere full of white dot, and I think I could refound this artist. So let's say Japanese artist. Tak, tak, tak. Yeah, I think it's here Yaoi Kusama the polka dot. I think is this artist. Yes, this one. Yes, this is Yaoi Kusama. So I've seen one of the exhibition few years ago, and this was this one, Yaoi Kusama. This was this exhibition at La Villette Paris, and it was really amazing to have all this suspended sphere with some dots, and it was a really a great universe. So I think I would love to explore this. And as you can see, it's really interesting to see all these little dots here and here. So yeah, why not? So as you can see, it might be really interesting. So that's the main idea. Working with some sphere and dots, etc. So that's for the design part. It might be really simple to do, in fact. Having some color, and maybe I would love to sample color into a ramp in order to have some variation. You may remember I love to play with ramp, as it's some kind of basically a way to draw curves in one dimension and sometimes two dimensions, so it's really interesting. So yeah, I would love to play with some sphere and with some dots and etc, etc. Okay, let's cut the scene here. Another thing I want to play with, it's we haven't played with this one, with this idea during all the stream. Basically, we've made a lot of different things, and as you can see in my Instagram feed, which is here, we've played, so this one we just seen it. So okay, shape blending, we've played with some shape on the vertices which can fall down. We've played with some shapes where fur can grow. We have some furry ball which pops, furry balls with light casting into it, simple furry ball, another cotonous ball with a more undefined shape. We've played with some kind of rocks, crystal shapes made of marble, terrazzo, gold, some natural shape with flowers, also flowers which then detach from the body and then fly to the wind. We have this one also, blending natural shape. We have this golem, which is not, I think a little bit too, it's a little bit too dark, but a rock man with some light going into it. Some like of tiles, lighted tiles, and with some hole inside the body. Some say we might see some string into this one. A little also cubic element which move with movement. So yeah, we made a lot of different things, like this one also, some cube spawning into it, and then the balls, the terrazzo balls, and the first one. So yeah, every time we played with the fact that our instances are just spawning on the vertices and follow the vertices. So yeah, why not? This is one. But the one thing we haven't played with is some kind of an iteration of this one, the fact that we will use some physics. So maybe we can spawn some ball into the shape, but when the body just move, the vertex is not the position of the instance, but it could be an attractor. So basically, if the end is moving, the ball will just go to it and then rotate a little bit around, then go back, etc., etc. So we can have some kind of trail because the shapes will keep trying to go to this place. I've recently I had decided when I was walking home tonight, but then I was scrolling Instagram and I saw this great work from so it's Casey Farina Art, a great account. I follow him. I've seen his work. I've seen his work a lot in various posts, and I was surprised that I was not following his work. But yeah, it's really inspiring. And one thing he's made is this little installation, video installation made with Unity. Also, it seems to be made with Unity, and it's also a body study, a body interpretation, a study about movements. It's clearly more complicated than the things we've made here, because you will see the body is made of various stratifications. We have some global shapes which make the bodies, and we have some big shapes which can play with physics and moving all elements and playing like balls full of helium, and we also have a little bit of trail around some important area of the shape, which can be the hand and the foot, etc., etc. So it's really impressive, all this little stratification which basically make the things working. So it's really, really impressive. And you have what we want to try here. I really invite you to see specifically this post, which is the full body interpretation, the full film, where the body will pass through all different kind of interpretation with different shapes and material, etc. But as you can see with this little movement, you can see it's look like the elements, the little elements here are not really placed on the vertex, on the vertices. It's really moving, following some kind of an attraction. So that's what I want to explore, and it might be really interesting. So we will try to go to this part and go to the dot part. So it might be really simple, and because we will use oh, nice. Thank you for joining the field. It's really impressive. Your work is amazing. And yeah, because it's following the vertices, we will make some sphere following the vertices using some kind of attraction, and because it's a sphere, the problem I have with the rotation matrix will not be visible because it's only a sphere. So sure, I would love to talk with you later. It would be a real pleasure. So let's start our little experiment. I will need to make a new scene here, and as always, it's not the best way to do that, but it's helping to keep every part of the old iteration by simply duplicating everything. But let's try this part. So as always, I would need to duplicate some elements. We have nearly 18 of each controller, each GPU mesh controller. So really, I think next week will be dedicated only to to clean everything and to be sure to simplify everything and reduce the number of controllers, etc., etc. So yeah. So this is the GPU mesh controller, and where is my controller? Here it is. So let's change this part. Hopla, tac, 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 and okay. Let's wait until it's compiled. Then we will create our little new scene. Okay, it's good. Let's create a new compute shader based on the one from yesterday, and we would need also a new material from yesterday. I'm not sure we will use the one from yesterday because we would need to retake a lot of the material, but okay, let's simply change some of it. So let's get rid of some of the old bones we have here. So we can take, okay, we can get rid of everything, in fact. So I need a controller and I need a GPU mesh controller. Let's start with just few instances, so 100 might be enough. For the mesh, I will take a sphere. Let's start with a mean scale, a static mean scale, so just to be sure that we have everything with some kind of rotation. For the material, we would put the material for the day. Okay, and okay. Then the compute shader would be this one, and also we would need a ramp in order to distribute the body, and we will use the same because I kind of love the way we distribute the body lately, but we could make another one. Okay, then we would need a new shader. So you know what, let's go back with everything we have here, but we will simplify each element of the shader. Okay, so instance 19, we will use the element 19. Right now we can get rid of the ramp light, I think. Yeah, the ramp light, we can get rid of this part. I was thinking which one is the ramp light, but yes, this was simply the way to having our little light. And we can get rid of the layup. Okay, this. Okay, so now it's simplified. And let's get this part. Okay. And then go back to the compute shader. No, we need to change also the vertex shader, because remember the vertex shader from yesterday, we had this little change here in order to going from the shape to a sphere. And then the compute one, which is here, and in the compute shader basically we would change all of these parts, so I don't need the sequence time, in fact. Okay, we can get rid of this part also. Let's change this also, so we could keep having something really simple. So I think that might be everything we need. And the alpha would be 1 for the moment, sec time would be 0 for the moment, and the mode loop would be 0. So okay, no need for the value right now. Okay, we have it. We have our little guy here. So of course, if we want to simply just having the position to the vertices, it would be something like that. We would need to say that the position is equal to the position at the index, just to be sure, and we know that is a vector. Yeah, it's a float 3 by 3 because it's a vector 3. So now we will have our little guy moving. Okay, so this is our sphere ball, and let's get rid of the skull elements right now. We don't need these parts, and we'll just focus on something that we don't want to do. I'm changing something. Yes, material 19 could be, yeah, this one. Okay, perfect. So now we have our little ball guy made of rubber ball or sphere or anything. Let's check if I prefer to check sometimes if I haven't override anything, just to be sure. It would be a shame. No, anything has been override, so it's perfect. Okay. So as we need to see if our little shape really follows this position, we would need to change a little bit the size to be sure. So let's say 25. I think it would be big. It would be too big, but okay. 0.1. Okay. Now it's kind of interesting because we could see the way the shape will go to this. So let's focus for a moment on the way we could make an attractor. Remember we made some physics. We've used, I think it was not, it's earlier physics. So yeah, it's not Verlet, it's earlier, and in the earlier physics system we would have something like the acceleration would be equal to the force divided by the mass. So the acceleration would be equal, would be the addition of all the forces divided by the mass. Okay, so each force is divided by mass, of course. Then the velocity would be simply the actual velocity adding the acceleration. Then the velocity would be, of course, limited. So velocity max mag would be, of course, equal to the max speed. So velocity is always velocity dot equal this. Velocity dot mag would be simply less or equal than the max speed. So this is the way to clamp the max speed. And of course the position would be simply adding the velocity, and at last the acceleration will be multiplied by 0 because the acceleration will be reset for each frame. So this is the basic system for the physics, the earlier physics. And I think I will try to work with an attractor using the earlier physics. So a way to do that might be through adding a force, I think, to the target. So let me check. Something I really love to check when I want to play with physics, in fact, is going back to one of my earlier loved in terms of creative coding, which is processing, which is really a gold mine of behaviors. And I've made a lot of projects using processing. I've write some libraries about it, using GPU, using Cheddar. I write compute Cheddar inside processing. So processing for me is some kind of sketchbook, it's look like my how can I say that? Oh my god, my vocabulary is not following me. It's like my notebook. Yeah, it's like my notebook. So you've seen me during the stream. Quite often I'm taking my notebook and I'm sketching something about the idea, trying to find some algorithm using visual system, drawing vector or drawing linear interpolation, drawing curves, etc., etc. Basically, processing it's just that now for me, because I still use processing a lot when I make a lot of projects for myself, or even for the studio, and all the remarching experiment I've made the past few years, it was last year I think, was made using processing because it was easier for me to set up a little quick scene for that. So I love to go back to this sketchboard. So yeah, what I want to talk about is this amazing book, which is Nature of Code, and I think every creative coder which working right now need to know this book. And this book is amazing. It's written by Daniel Schiffman, which is an advocate and someone who is on the board of processing.org, and this is really amazing because Nature of Code is basically a book about physics and natural behavior. It's focused only on 2D, but it's really simple to add a third dimension into it. And Daniel Schiffman made a great work in simplifying every physics system into this book. Also, you need to know that all the contents are available for free. So if you need some codes, if you need some chapter, everything is available for free. But if you want, and I think you will need it, if you want an hard copy of this book, which I have personally at the studio, because it's some kind of a support from his work, you can buy it on various stores, and you can make also a donation. So really it's a gold mine for behavior. So yeah, he had a lot of things, and for example, when we talk about forces, I think he had some attraction system. So yeah, this is the attraction. So let's look into it. So basically this is the attraction. So as you can see, it will be attracted and then it move along, etc., etc. So there is a lot of things we can make. We can make an attraction, we can make, so it's like some kind of a seek, in fact, a seek behavior. We can make an arrive behavior. The arrive behavior is quite interesting because the shape is moving and then quickly slow down until it reaches its position and then it's fixed to this position. So let's try to focus on this thing. So in terms of examples, so the first example are really just the basics of everything, but in the agent you can have all, in the agents you can see all the behavior, and I think the first behavior we want to check is the seek behavior. So as you can see, the seek behavior basically the little vehicle try to reach its position and then it's kind of rotate around. So this is really what we want, because we would have some kind of movement like a pendulum for the end, for example, and we would have some kind of delay in the seek behavior. So how does it work for the seek? As you can see, we have a seek behavior, an update, and the display is basically taking care of the drawing. So the update, we've written it inside our compute shader as a note. So the update is basically the way to applying everything. So as you can see, this is the update. We take the velocity, we add the acceleration, we limit the velocity, and we take the position and we add the velocity, and the acceleration will be multiplied by 0. On our little code here, we've seen that we have this little line which is acceleration is equal to the acceleration plus the force divided by the mass of the object, which is basically this function here. So apply force, we take a force, we use the acceleration, we add the force to it, and then we say we can divide it by mass, so we could add mass here if we want. And this is what we want. This is the seek, and basically the seek is really simple to understand. So the idea is we need to compute. So I have my vehicle here, for example, okay, and this is my target, and I want the vehicle to go to it and then kind of move around and just try always to go on this area. And if my object is moving, I want to follow him. So the first thing we need to know is the vector going from the vehicle, okay, the position, the shape, our instance, to the target. And this is really simple because it's basically the position of the target minus the position of the vehicle, which gives us this vector going from the vehicle to the position. So this is the desired behavior. So this is here. Then we would need to scale this vector to max speed. So this scale here, the set mag, is simply taking the vector, normalizing and scaling it to a max speed in order to have some kind of speed vector. And then we need to define the steering behavior. So the steering behavior is taking basically the actual velocity of our shape. So in fact, for example, my shape is going for example forward, and then I need to steer this vector to the desired force. So basically the idea is to take the desired velocity. So remember, this is the velocity going from the position of my vehicle to the target, so this vector, and I would simply say that I am taking my velocity minus this vector, so I would get my steering behavior. And then of course I will limit this behavior to a max force. In order, this max force will define how the vehicle will simply change this position. If the max force is really big, for example, my velocity will steer really fast to the position. If it's not big, we have the velocity will be simply just moving a little bit, and then it will take some time to arrive to this position. So this is the way we will limit this, and then we will apply the force to the system. So let's write this down in our compute shader. So this would not be our position right now, so we need to find, okay, the target. So the target is basically the position buffer, okay, at the index, because our targets are moving all along. So this is the target. We need to know of course the desired position, which is the first part. So the desired position is basically our actual position minus the target. So this would give us the desired vector. Okay, then we will need this desired to simply scale it to the max speed. So by doing that, the main idea is to normalize our desired vector. So we will normalize it. Then I will multiply it by the max force. We will also create some kind of max force here. And remember, Unity the Unity system is can be really tricky, because as we have seen on the past experiments using physics, if we put a vector of 1, our element will go really fast. So let's start with some really small speed for the moment. So this is the max force. Okay, so this is the first part. When we have that, we need to know the steering behavior. So this is also a vector, and the steering behavior, so the steer vector, would be equal to the velocity, okay, to the desired vector. So this is the desired vector minus the velocity. Then we will need to limit this element. So remember how we limit this element. We've seen this on the compute shader on the 17, I think, and we had these little things here. So basically we've taking the magnitude of the vector, and if it's bigger than the max speed, then we will normalize the vector, then multiply by the max speed. So this is the main idea. So go back to our little compute shader here. So we will take the steer vector, and we will limit it by saying that if the length of the steer vector is bigger than the max speed, then we would normalize the steer vector and multiply it by the max speed. If not, we would use the steer vector. So this is our way to limit that. Of course, we would need to also create the max speed value. So let's say 001. Okay. And next, we would need to apply the force. So we have these little elements here. So I'm happy I haven't delayed them. So let's continue. Okay, so basically we need to say that the acceleration, to the acceleration we will add the steer behavior. So we will apply the force. Then to the velocity we will add the acceleration. The velocity also we would simply limit this by saying if the length of the veil is bigger than the max speed again, then we would normalize our velocity multiplied by the max speed. If not, we would use the velocity. Then to the position we would add the velocity, and at last we would take the acceleration and we would multiply it by 0 in order to reset it and say, okay, acceleration will be 0, no magnitude. So here we are. Of course, I would need, as we made the last time, we will need to simply bind our velocity and acceleration just to be sure it will be updated every time. So if we are correct, which it seems, but it might be an error somewhere. As you can see, we have something here. I said the velocity, but it was vel. We could have some kind of steering behavior. So let's try. And we don't see anything. Why? So let's try to simply change. Okay, so if I set this, so if I don't take this part and we set simply, okay, so this is the position. Let's remove this little guy here. We would have also the position. Okay. We take the position here. We have the acceleration, we have the velocity. I remember yesterday we put some value inside the value of the acceleration. No, we didn't put any value inside of it. So the slot are ready. The slot are available. So the target, we have the position, the desired. It might come from the max force. So let's try with a value of 1. So remember we made this, so this is correct. Something I really don't understand. So let's say we want something like that. Okay, so now we have this. Sure. So if I say velocity multiplied by 0 and just scaling this just to be sure. And now we don't see anything. Where our little elements has gone. Let's redefine the steer behavior just to check. Let's define this as a simple float 3. 0, 0, 0, 1, 0, for example. So just to be sure that on the first part, which is on the update part, which is here, this is not a problem. Okay, as you can see, it's moving. So we've simplified, normalized the value, okay, by the max speed. So let's say the max speed would be 0,025, it would be something really stable. Okay. If I want to move really slowly. Okay. So now it's moving really slowly. So this part might be good. Okay. If we not apply the steer but the target, so as you could see, we are moving up, but with also this is quite interesting. If I take the position minus the target, the elements are going up. I think I've made a mistake. This is target minus the position. So the error is here. I'm in the wrong vector. Okay. So we would have a max. The max force would be the same. So target minus the position. This is the desire, and the steer might be that. And again, we don't see the steer. X, Y, Z. Oppose vel data, this is it. Oppose vel data, okay. So why do we have this? It might be something here. Let's use for all of that a normalized vector. If I normalize the vector, I get a an error. I'm getting some error, okay. So the target is basically XYZ, the position is also XYZ, so not a problem here. But the steer, which is taking the velocity, so might come from that. I'm not sure. Okay. Not at all, everything is disappearing. This is quite strange. We don't use the rotation matrix, we don't use the scale matrix, so that is okay. But the translate, really, we don't do that. So even if we have really a small system, everything is disappearing. So why is that? I'm not sure. So basically, if I say 0, you would see it will appear by magic. Okay, so now it's appearing. But if I say the vel, it looks like something of a cast problem, but I'm not sure. We are binding this, so this is not a problem. So the random index is respected, so not a problem at all. So why does the position doesn't want to be this? This really just makes things why does it make things like that? If I say that, it would work. Not at all. So acceleration plus equal desired, desired velocity plus equal acceleration. Everything is set here. We're starting having something. Okay. This is the desired. But when we say something like that, it's disappearing. Of course, because of the max force. I know this part, so not a problem. I'm starting thinking about a way to rewrite the normalized value, because when I use a normalized value, everything just disappeared. So why? Yeah, I could say something like that, but I could take the desired vector divided by the length of the same vector, sure, multiply by the max force. This would simply rewrite the normalized system, but it's not appearing also. So the sphere are really elsewhere. We don't know why. But if we don't take the desired, it reappeared. Why? Okay. Let's keep moving. What's happened if we change this by the steer? Does we lose everything? We don't lose everything. Okay. So basically this is the normalization, which seems to change a lot of things. It's working a little bit, but not as I thought. Maybe we can try to reduce the value here. Let's try to show the body so we could see how it's moving. So we have this. So basically it's really too not enough speed to follow the elements. So if we could say something like that. Okay. So yeah, we have this kind of thing we wanted, especially we have some kind of you know, some bouncing, etc, etc. So of course, as all the elements share the same max speed and max force, we don't have the desired, how can I say that, full desired the behavior, but we will need to change this a little bit. Okay, so it seems our system is quite good, but it has some kind of problem with the normalized system, so we can get rid of this part. Okay, so a way to change this a little bit could be trying to use some kind of randomization. So for example, what's happened if we put max force to 5, which is really big? As you could see, I think the element will just be here. So okay, so let's say we have a mean of 0.1 or 0.05, for example, which is really small, to 0.25. So let's check 25. We could basically take the same, in fact, the same max force. So remember, we had a max force of 0.5, but we will simply divide it by the mass of our element. Now we have this kind of jiggy element. So yeah, let's add some randomness into this. Let's take some elements which can have some size of 1, and some of them could have some size of 25. Okay, so now we have our element. It has some kind of latency, so all the shapes are really following the elements. So okay, let's continue this, and now we can simply say that the acceleration, remember, is basically, this is what we have here, is basically let's go back here. So the applied force is basically the acceleration when we add the force. So acceleration plus equal the force. So it's himself plus the force. But we can use also the mass, which can be really interesting, because if we have different mass, we can have this kind of latency we want per instances. Let me rethink about everything, but yeah, velocity, add the acceleration, we limit, we add the velocity to position, and the acceleration will be multiplied by 0. Okay, no, so this is okay. So yeah, we could say that the steer would be simply divided by the mass, which is some component, and we take the y component, but as it's a sphere, all components are the same for the size. And let's see what's happened. Whoops, everything is going crazy. So it's good to know that everything is going crazy. It's quite strange the way it's behaved. Dividing will go with something really crazy, but multiplying will do nothing. Might come from the fact that we are using some kind of matrix, but I'm not sure. Remember, we could say something like that. So now we have this, which is basically really crazy. Okay, because we have a max speed of 0 of this one, of 1, but we could simply reduce it. So it's really not perfect. What happens if we put a max force of 1? Yeah, it's really jiggy, but we have some kind of latency, of course. We could see this. As you can see, but it's really too big. So now let's try to say, instead of multiplying this by the force, we would be trying our little guy here, but no, it's the same. And if we try this, of course we would have also the same. I really don't know why my so normalize this would be okay, but using this normalization is basically a problem. Why? Maybe it's a problem rewriting everything, but not sure. Let's try something like that. Row 3, desire 2, and let's try that. We should end up with the same behavior, but no, if we use this normalization, basically everything is going crazy. So if this part is not working, we could change this part. Okay, so this seems to be really It seems to be not working, but we could use the ramp size in fact, because it's depend on the element. So we could use something like multiplying this by a linear interpolation between the max force. So as we would say, something like 0, 1 to the max force by the ramp, for example, and this might change the way it's behave. Yes, I forgot something, it's LEP and not LEPR. So now it's a little bit more different. Okay, so we could simply say max force, min force, max force. So let's say min force, and let's try something like that. Okay, so we will use min force, max force. Okay, and we could also steer this by the max speed. So let's say steer would be multiplied by a linear interpolation of the min speed, max speed. So maybe the max speed could be 0.5 and 0.01, for example, and based on the same thing, so min speed, max speed, and based on the ramp also, okay, which is this element, and let's try that. So now we have this behavior which starts to look interesting. Some of them are moving really fast, and some of them are really small. So which one are which? Let's check. So let's check something like that, 0.505. So we will have the same. So as you could see, now our body look like a cloud one. It has some kind of woogie. Okay. So I think if we look really, so let's reduce a little bit. If we look really to our little guy here, it seems the big one are moving differently than the other one. So let's check the scale, for example, because we haven't reordered the scale. So this is the scale. So the big one are following, and the small one. So I think the big one might be slower than the small one. So if the big one can be slower than the big one, which this means that we need to invert our ramp. So here we need to say 1 minus, which is the same here, 1 minus, because the little one would be would be speedier than the big one, which would be, as you can see, we have some bouncing inside of it, so it's kind of really fun to see how it's behaved, just boing boing boing, because the foot are really going with some kind of element. So yeah, so this is the min force. So let's check, and let's try to implement our little value here. A better way would be to create some kind of sliders. Okay, so this is it. So 0.5 would be, yeah, if we disable the body, which is what we want, we have some kind of strange body moving, bouncing, and it's kind of interesting. Okay, we could say something like 0 instead of 0.05, something like 0.5. Let's try that. 0, 1. Kind of like the way we have some kind of... Okay. I think this is more interesting because we have some bouncing inside all the elements. So it's clearly changing the shape of our elements. Let's check what's happened if we add more elements. So let's say 1000. As you can see, we have this jiggly body, and this is basically what I wanted to explore. So maybe it's 0.25, it's too big. Let's say 65, just to avoid the Smiley Tech Gaming say Halo 13, 14, 15, 16. What? Hello to you, of course. Hello to you. But the chat was paused here because of Hello 1, 2, 3, 4, 5. What? Okay. And Smiley Tech Gaming, hello to you after the 17 check. Yeah, the screen was on my left side and I haven't seen it, so I need to find a better setup to stream this. The bouncing is very interesting. Okay, so 65. Okay, so next would be the speed. Okay, so let's go back with some kind of simpler min-pig math just to focus on the speed. Okay, where is my Unity project? Is here. It seems that the bouncing comes from, yeah, the bouncing is really here. It's come from the element. So this is the base system we have. Let's reduce again just to be able to see everything. Okay, so now we're seeing everything. And now we can try to change the min-pig max speed. So let's try something like that. Let's try from 001 to 01. So we use the bigger one would be the small one seems to be having a bigger speed than the bigger one. Yes, okay. So for this one, it's clearly the inverse. So going back, something like that, and we would have the same things because I just inverted the things. So for the small one, this is too big. So 0.5. As you can see, we have some kind of bouncing to the 0.5. It's look like it's okay. We could say something like 25. Look like an elastic system, 25. Okay, and this, let's say instead of 1, 0.75, just to see how it can move a little bit. 65, for example. Yeah, I think this could be the trick. And let's use everything And now we have what I wanted, which is some kind of cotonous, cloudy little guy. Okay. So if we don't use the size here, and if we simply say that the size is basically the size which is stored in the elements, let's try to change this a little bit. So let's don't use the ramp for this, okay? But oh, you know what? I can simply take everything, but use a random ramp. In fact, I can create a random ramp, so I would not need to get everything. So if everything is correct for us, we could start thinking about the way we would shade our little guy here using our little body system. Yeah, I'm seeing the chat now, and I now that the chat has not as updating. Okay. So this, by the way, this part belongs to science and technology, bro. Yeah. I know the classification. The classification of the stream belongs to science and technology, but as I want to focus also on the design part, because yes, it's technical, but we are simply going technical in order to create some behavior, some nice animation, and some nice visual, etc. So yes, it's for me it's more like a design part than a tech part. That's why my Twitch on stream is on the art category and not on the science and tech. Okay, so I wanted to try a random element, and we could use this one without any red. Yes, it's RVB, so let's try with TLS. Okay, and now it's better. Okay, so now I have a purely random 1D ramp which I could use in order to define a random body. Okay, so it would be a random based on the y-axis, so why not? Okay, where is our little ramp? It's here, and it's a 1D ramp, and it's a ramp 4. So it's kind of interesting, but I think it would be more interesting if we really use the ramp we've made in order to create a recognizable body, because as you could see here, we clearly see how the feet are bouncing on the ground, which is interesting, but because everything is really random, we have some strange behavior. So let's try to return to something more interesting. So we have the ramp run, for example. Okay, then the ramp the ramp 1. I use the ramp 0, so let's try this one. Interesting the way the feet are growing. And let's use the 4, not the 4, the 4 is the random. Let's go back to the let's go back with this one. Really bouncy. Maybe 500 would be better as a design system, because we will use some dot into it, so okay. So here we are, some cotoneous and vibrating man, and really interesting. We could have thought to the ramp size in order to give a little bit of randomness into our min max speed. We could say something like that. So float random force offset. I would call this like random force off. I would use for the size, so this would be the ramp plus a random value per instance, which could be this little oppose, because the oppose W, remember, it's a random value, and I kind of prefer this one than the one we generate with our random function. So yeah, ramp size plus w.oppose, and because now we have a value going from 0 to 2, we need to rescale it. So by saying simply divided by 2, and now we can use that here, and we would have some randomness, so each time we have the same. Yeah, this is more visible on the and more easy to explain. So now if I have elements which has the same size, it has also some randomness into its speed behavior, so it's more interesting. Okay, I think we've made everything we wanted on the basic system, so we could start work on the shading. Okay, so how do we make this little, so go back to the references, these little dots here. Let's think about it. We could simply create a texture and directly put it to the shape. I think this could be easier. So let's go back to the sketchbook. I think I'm eating my pen, because every time I take one, I've lost one. So yeah. Yeah, I think I would definitely create my own texture for that, because we have some randomness, we have some rotation, and the texture might be enough. I was thinking, this is why I was in fact drawing something about it. At first I was thinking, why not create a shader which generate the balls, the round, the white round, and it might be interesting, of course, yeah. But if I made that, the simpler way would be to take the UV, multiply it, take only the fractional part, so I would have a grid, and then I could feed the grid with some sign distance field of a round, and using a random per shell I can change the size, but I would end up with some kind of grid which is too uniform, like like the one on the back here or on the dress, and I'm not quite fond of this. I prefer this little sphere here. So the way that Aoi Kusama work, it's more organic, so I think I would go directly to Photoshop and create my own texture. It would be better. So let's create this one, and let's go to black and white, so we could simply use a ramp then to change the color. So let's create 512 to 512 texture. Let's take something full black. Okay, and now I can simply feed my texture with some rounding to it. So let's say something like that, maybe someone here. Let's take some reference on the side. Okay, so I still have Yayoi Kusama on the side, just to check the way we can also distribute so the balance, the contrast, you know. It's interesting to keep some contrast into the shape. So let's feed a little bit here, just to be sure that it's not on the grid. Maybe, yeah, it could be a little bit bigger. Oops, this one needs to be, for example, smaller. Another one here, which can be smaller here, for example. So okay, so this one could be here, this one okay, here one, another here, another from here, for example. Okay, the first one could do the trick. Let's save this and let's create a new folder, called it dots.psd, and then save a png. Okay, go back here, let's use the matte and let's feed with our little dot here, which is here. Okay, and let's see. So it's kind of interesting. Does my texture is stretch? Let's reduce the number to see properly the texture. Yeah, it's a little bit stretched, but it's stretched because it's applying on the shape. I could tighten this a little bit, thing like that. So let's change this. Where is it? Where is my texture? Okay, so it's on the repeat, but let's say something like clump. Now we basically see the seams too properly. Let's mirror. We could of course see the seams, so this is really not fully interesting to see it. Also, we might have a stretching problem somewhere, I think. Where is our sphere? So let's go back to Unity, create a simple sphere and put our shader into it, and let's see. Yeah, and why is it so go back to this. Okay, now we've seen. So yeah, this is what I was telling. Here we have something of a stretch here. As you can see, the texture is stretching all along. So if I say 1, for example, 1 1, you could see how the texture stretch on the pole. But this is strange because if we check the wireframe, it could not. It seems it would not stretch here. So it might depend on the UV, I think, but it could not be a problem. If we don't change, yeah. I think we will need to create a better. So the MIP map just get rid of the seams. So this is the best part. But I think I would need to open C4D and to change the sphere. Trying to see the shaded wireframe. So as you can see, look like there is a UV problem. Let's import a texture to debug this. So I have one here in the asset for developments. For dev, I have a checkerboard here. Okay, this is my checkerboard, not a problem. Okay, then in my material, which is here, okay, I could put the checker and see. Yeah, okay. Yeah, there is basically a UV problem on the sphere. As you could see, we have some blending here, so it's collapsing. Okay, so let's go back to Cinema 4D to try another sphere, and maybe we could use an icosphere, which I basically prefer because icosphere is okay. As you can see, this is the base icosphere. It's made of triangles, so it could be a better sphere for a lot of texture. So if we want to texture a sphere, it could be really a better one. So I will create a simple new material and I will put my UV texture in just for you to see how it behaves. Assets, there. Okay, so now you can see. Okay, so of course we have this collapsing here. This is the main problem with the sphere. We need to collapse somewhere. We could change other things. For example, we have spherical, we have cylindrical. So this is the way we distribute the UV. So again, cylindrical, we're collapsing everything. We have what? We have flat, which is basically a projection. Cubic, which make a lot of strange shapes. Frontal, which is again a projection. Spatial, again, it's a projection. Shrink, of course, and the sphere. So yeah, the spherical is the main thing we need to know. So we will still have this little problem here on our sphere. A better way would be to create a proper UV system. So just let's check this this little element here. So let's export this OBJ, and I would put in the model, and I would name it as a sphere, and let's try if we would have a better texture on it. So let's try that. First of all, the sphere is really big, so let's reduce it, and it would be 001 for going in from C4D to Unity. So now we have this sphere. Okay, not a problem. Let's go back in the proper size, and let's change again. We would have some strange behavior again. As you could see, the UV is not perfect. So I think if I change that by our little dot, it would not be perfect also. So if I said that, you could see that we have these little elements, but we still have some of this sphere which is which are totally outside our shape. But we could simply retake the texture just to be sure and try to avoid that. So let's reduce again. I want to have something more like the, okay, this is the, so a way to change this is simply try to update my texture in After Effects, in Photoshop. So I would have something like, so the 0 to F is correct, but then I have a triangle directly from this, and it's going to the 756. Okay, so let's do that. Oh, it's Black Friday of Insidium. Okay, so it would be something like that. I would have a cut here. So going back here, let's take my UV, putting it into it, and it seems that we have something going from this to this to this. So this is the available area. Okay, so let's use as our available area. So I will need to move some of the round, some of the ellipse directly to be able to see them, so it would not be too complicated, I think. For example, this here, this could be a little bit here without any problem, so this one could be a little bit smaller. This one would need to be, let's see, really smaller. Okay, and this one, if we don't want a cut, say something like that. Okay, and this one need to be here, and we could duplicate a little the little one we have here. Oh, we need also this one to be smaller to be sure to fit. Okay, so yeah, this one could be going somewhere here, for example. So yeah, let's try this as a PNG. Okay, so go back to Unity, and now if we changing this by this, hey, yay, we have this kind of little balls everywhere, little balls, little ellipse. Okay, so now I could simply change here my sphere model to the one we've used here. So this is this one, and if I click play, I would have this. Hey, yay. Okay, so it might be a little too many elements. As you can see, maybe we have too many shape into it, so we might want to simplify a little bit, because also if we take our sphere again and we put our shader into it, where is my sphere? It's here. And if I put some shader into it, where is it? It's here. Okay, I could use the tiling to divide it, the shape between the elements, but I would also need to offset, and then I would again need to cut. So I think it would be better to simplify everything. So it's not a problem to have less ellipse on it, because it's resulting of having very a lot of ones. So maybe we can simply try with, first of all, reduce the bigger one, so something like that, like this one, and like the other one here. Okay, and we can also say this one would be going off, maybe playing with few of them, for example, so you know, thing like that. Maybe another one just here, a little bit smaller, just for the example. Okay, let's save this as a PNG again, and going back here. So now it could be better. So now we can see the dots, so it's okay. We could still take all this and try to reduce them a little bit, just to add more white space into our visual. So for the non-designer who's checking this stream, the white space is the space between the graphics we have on our texture. And as at first I'm a graphic designer, I need to know to say that we don't need to be afraid of the white space. White space is really interesting. It can give depth and it can give a lot of things. Also, I don't need to generate map on this one because we don't want to see the seam. Okay. And now we have the basics system for our little guy. Okay. So the sphere is okay. The controller is okay. So let's return with our 500 element. So it's interesting because on the feet, as you can see, as the elements are smaller, the ellipses are smaller, and it can create some kind of a moire. And moire effect is really, really beautiful. So we still need to make a lot of little things because it's clearly not finished. So let's go back with our little guy here, our little sphere, and with our little material here. Okay, we could define a lot of things. First of all, we could simply say that we want to change the blur size in order to simply reflect the environment purely, so you can see my environment, which is here. Or we could add a lot of blur into it, so I think the last blur was 0.5. We could also start working with more emissive one, so I would give something really different and it was more glowy. But again, I think something like that would be better. The albedo emission is really the emission from the albedo, and here our albedo doesn't have any emission, so this is not a problem. I think I would also add some things to change the way it's reflecting the color. So something like a bump map could be interesting, even if it seems to not be applied here. I'm not sure why. Maybe because it doesn't have any elements. Where do we have something like an interesting let's reduce this element here and this one. Okay, yeah, now we can see if we use, for example, the agate, which has a lot of stratification, it's more interesting. We could use some metalness, so we would have a little bit of scratch into our little elements. Okay, so that's also interesting, especially if we add a little bit of emission, we could see them. But 0.1 is, I think, better. 0.05. Okay. Which one do we have? We have various one. The marble might be also interesting, and we have a plastic. I think the plastic might be also interesting, and the terrazzo. So go back here and try other. Oh, the shaded. There's a lot of glow into it. Oh yeah, but a lot of glow, but I haven't set the light. So okay. And I don't move the proper system, which is here. Okay. $25. 0.25 might be more interesting. It would give some kind of little element here. So yeah, we use the metal, but we have other metallic. So this one is a little bit rough. You can see we have some little noise into it. This one also is interesting. The marble is interesting because it has this nice reflection. And the plastic one, and the plastic is not really interesting. I need to fix this. Okay, so this is the plastic one. Quite of interesting, the plastic one. I think so. I think we will go with this one. The ruggedness, let's add the ruggedness of the plastic. Okay, the alpha test, no, not a problem, we don't use the discard. Oh yes, this is the basic system. So now we need to add some color into our little guy here. So we could again use a ramp. And did we what do we put in the original position? This is the original pose. Okay, so not a problem. So you know what, let's try to add a ramp into it. Okay, an albedo ramp. So I will say something like that. We use that. We will say this is an albedo ramp. Okay, so it's a sampler 2D. And let's say that the color will be a float fixed 4, which would be our ramp, which is basically a text 2D of the albedo ramp. Okay, so albedo ramp using a float 2 as a UV, and we will use in.oppose.y divided by the max 8 and 0.5. So I will use the normalized position on the y-axis. Okay, so of course I could multiply by the color and by the ramp. So in this way we could add more color into our little dot guy. Okay, so let's try with the ramp. Where are the ramps? So the ramps are on the ramp folder. So where is it? Ramp. Here it is. So I have some ramp here. So go back here. Could use this one, for example. Oh, it will be blacked, so it will not working. It will only gives color directly into the dot, and I don't want the dot to be colored. Okay, so what we could use is again a linear interpolation, which is basically a lerp between, on the black I want to have the ramp, on the white I want to have the white, so 1 1 1, and the value on which the linear interpolation is based, so the offset, is basically the value of the RGB. So directly from the texture, which is black and white. So we could feed some color directly into the black and having some yay little guy with little dots into it and some elements. So it seems sometimes the opposite seems to be negative, that's why we have something like that. So let's try to say we want to saturate this value just to be sure it's clamped, so we could get rid okay, I think we have get rid of the oh no, we have a colorful element on the foot, only on the foot. Okay, but now we can use different ramps. So this one was interesting, we have this one which is really colorful, we have another one here, this one is really interesting. I think I will go with this one. And do we want to use the same things as the artist, Aoi Kusama? This would be a black dot and not a white dot. Yeah, it's better. It's more interesting to have this kind of little black dot. Okay. So of course we didn't change the orientation of the shape because of our matrix problem, but let's try with other shapes. For example, this one, a cubic shape. It's also kind of interesting the way it's moving. So yeah, something that might be interesting. So where is our sphere? Our sphere is named default and it's here. So we could also try to add another layer of shapes into our little guy here. So remember we use this ramp here. So let's try to say we want something like, I use 0.5, but we can also say ramp y, which is basically the value on the y-axis for the UV, which is a float, and at first it could be 0.25. Okay, and if I use something like that here, where is it? It's here. Okay, so now I'm taking the color on the first ramp, and I could also change to take the color on the other ramp. Oh, I made a syntax error here, and also I think I forgot to declare my float value. Yeah, okay. So let's launch our element. So yeah, if I say 25, I'm taking the first value here, but if I say 25, I'm taking on the purple. So it might be interesting to add a little bit of randomness into it. Okay, so that was my value system. So remember we add some random value in the oppose here. So we could simply say something like that directly here and get rid of this element by saying in dot oppose dot w, which will mix our little ramp between these two ramps. and now we have something like that. So really colorful, really powerful. It's kind of interesting, and yes, it's I kind of like the way it's jiggling, you know. It might have too many elements, but let's try to reduce a little bit by 250, for example. Yeah, we could, especially for this one, we could add a little bit of but I think it's quite good for that. So I think this means it's the end of the stream, because it was really easy to make this one. We had sometimes to tweaks, especially the physics, which was a little bit hard on that one, but it was quite fun to make this one. So I hope you like it as I like it. It's simple one, but it's like some jiggly elements, and I kind of like that. What we can try, I'm thinking really about this. I think something that might be interesting would be to maybe add a little bit of randomness into this behavior. So let's try something. I'm really not sure of what I'm making right now. I might be end up with something really not interesting, but let's try to say we want to float 3, okay, and we want to add a curl as a force to our behavior. So you know what is it? It's a curl noise, so we could use kind of the same value we used yesterday, especially on this one. So we had 3 value: curl in, curl speed, curl scale. So I would simply duplicate this, okay, and we have this little curl, and we could say to the acceleration after the steering behavior we could add a little bit of curl multiplied by the curl scale, and see how it's behaved. It can be really messed up, so I'm not sure. Yeah, as you can see, it's a mess, because I think the force is really too big. So let's say we want something like 001, for example. So yeah, now we have a little bit of curl, so it could change the way it behaves. So we could play along with the behavior, and we could say a lot of things. So now it's more jiggy, it's more interesting. We still recognize the way it's moving, but as in the Casey Farina work, it's sometimes you try to see where is the body, so it can be really interesting. So if we want to slow down this we can change a little bit the curl speed here by 0.5 for example. So this is what I meant at first when I said that we could create some kind of a trail, you know. So this is, I'm quite fan of this one. Something we could also change is, for example, create some kind of states. So this is a hack. Okay, so let's say we want to set the acceleration, and basically, so I will comment this part, and I will set this by simply saying that if the modulo of the so the mod time, okay, so where is our mod time? Yeah, this is it. So we could say if the modulo of the mod time, so if this mod no, I don't want the mod, sorry, I want the loop, the modulo of the loop. Oh, sorry, yeah. So because basically here we're only using the physics, but we could say something like that. If modulo of the loop equal to 2 is 0, so if we have an even number or not, it depends on the elements. We could have something like the accelerity could be a steering behavior. If not, it could be a curl behavior. Okay, so it could be a curl multiplied by the curl speed. So we could simply moving from following to curl to following to curl, etc., etc. So if we fix the time, for example, because here the time is really not fixed, so let's say 4 seconds. Okay, so let's try something like that. And then it go back, and then it explode, and then it will go back, and then it explode. So you know, you can have these kind of things. So as you could see, the curl scale is really big on this one, so it's really a big curl. So let's try to change it. It's also an interesting behavior, in fact, especially when it's come back. So this could be a way, and now we could also say that now that the time would be purely random for each instance. So sometimes it will follow, sometimes it will go to another place, then it will go back, etc., etc. And you could have something more different. So because it's moving really far from the shape, it's not really interesting, but as you could see, it's really a big behavior. We really need to slow down this a lot if we want to have something interesting. So it's interesting, but not really, because what's interesting is going from following to curl to following to curl to following to curl. So I think we will explore that tomorrow. But these parts where with randomness too many curls happens and we don't see the body, so it's really not interesting. So let's go back with this little guy here, which seems to be good for me because we had a little curl directly on the shape, and now the shape are quickly moving. So I think it was something like that, to have some curl moving. Yeah. So of course it could be more interesting if the element were rotating, which we can try. I'm not sure about the way it will behave on the rotation, but we could try that. So it was on the compute shader, I think 17, when we try to define this rotation. So we could try this on our little compute shader here. But as I said, basically my rotation seems to be break. Broken. Seems to be broken. My rotation seems to be broken. Oh my. Forgot how to speak English. Okay, then this is going here. So because this is the physics, so this is going here. So we can try with this. We have the vel, we have the up the tier. So does it work? So let's check if we change any of the vectors. So we have the same thing now, so this is cool. And now we can apply this rotation, and let's hope we'll have something interesting. Yeah. I'm not sure about the rotation. It's give a lot of things to focus on. I kind of like the way it's fixed. So I will not activate it. So yeah, here it's better because we can see the dots. Okay, so this is the end for tonight's stream. We've made our little guy walking and having this behavior of the elements trying to following the shape of the body. which is a thing we haven't made before. So I hope you like this stream, and if not, I'm sorry. Do not hesitate to tell me if there is something you want me to change and to do for the next time. So yeah, we will have, I think, few more stream trying to make a new body. I have another idea, basically a little bit like this one, but with some butterfly, so having some butterfly trying to follow the shapes, etc. So it might be really interesting, instead of having some ball, having some butterfly using a vertex animation texture. So it might be a little bit longer to make, because I will need to make the butterfly or find one and then bake it into a vertex animation texture. But I think this could be a beautiful way, and this one we've made is the basic system for the butterfly. So we've made, I think we have more interpretation to make, and maybe the last one would be Sunday, as I said yesterday, because I would like to keep the next week, not to stop the code November, because it's important to follow the rules which says to make a code every day, creative coding experiment every day, but because as I want really to continue this experiment, I think I will pass the next week trying on debugging every little bugs we have somewhere, trying also to clean everything, to set up every scene, because the first scene doesn't have the reflection, etc. So trying to make something complete as a project. So the last week of November could be a nice week for the reset, as we call it, to retake everything, clean up a little bit, try to find a way to simplify every code, every file, because we have a lot of files. So a lot of files, there is some we cannot simplify, but a lot of them can be simplified. I think especially on the shader part, for example, or the controller part, etc., etc. So we'll try to focus on this part. So thank you for following this stream tonight. I hope you like it, and see you tomorrow. Bye everyone.